Hello my dear children, welcome back to my channel. This is Vidya Prabhu, your math teacher here. Today's session is about class 10 NCERT chapter number 3 pair of linear equation in two variable. So far we have discussed about how to solve a pair of linear equation by using graphical method. The next topic is about we are going to analyze. Without drawing a graph, we can analyze whether the given pair of linear equation have intersecting lines or coincident lines or parallel line by comparing the ratios. We know that the standard form of the pair of linear equation two variable is a1x plus b1y plus c1 equal to 0. The standard form of linear equation in two variable is a1x plus b1y plus c1 equal to 0, and the second equation a2x plus b2y plus c2 equal to 0. We know the coefficient of x in the first equation as a1 and the coefficient of y as b1 and c1 the constant term. Similarly, for the second equation, the coefficient of x as a2 and y b2 and the constant term c2. So now by using the coefficient as a1, b1, c1, a2, b2, c2, without drawing a graph, on analyzing the coefficient, we are going to analyze, by comparing the coefficients, we are going to analyze whether it is an intersecting graph, parallel graph or coincident graph. First thing, if it is an intersecting graph, what is the meaning of intersecting graph? The two lines intersect at one common point. So they have one unique solution. If a given pair of linear equation is when it is an intersecting graph, if the ratio of the equation a1 by a2 not equal to b1 by b2 not equal to c1 by c2. If all three ratios are not equal to each other, then you can understand that the given two equations, the given pair of two equations forms an intersecting graph, which means that they have a unique solution. They have one unique solution. If any pair of equations has a solution, then it comes under consistent. So intersecting graph is consistent. The next, coincident. What is the meaning of coincident graph? The two lines overlap each other, right? Coincident graph. When this condition occurs, if the ratio a1 by a2 equal to b1 by b2 equal to c1 by c2. If all three ratios are equal to each other, then they have infinitely many solutions. If a given pair of linear equation have solution, then it comes under consistent. And also, since the two lines coincide each other, one on the other, it is also dependent on each other. The coincident line is an consistent and dependent. The next pair of graph will be a parallel graph. When we will be getting a parallel graph, if the ratio a1 by a2 equal to b1 by b2 not equal to c1 by c2. So we know that the two lines will be parallel to each other. There is no point of contact, which means that we don't find solution. So no solution. If any pair of equation does not have a solution, it is nothing but inconsistent. The linear equation, the given pair of linear equation is inconsistent. Let me explain. Without drawing a graph, by analyzing the ratios, we can conclude whether it is an intersecting graph, coincident graph or parallel graph. The ratios for intersecting graph, a1 by a2 not equal to b1 by b2 not equal to c1 by c2. Intersecting graph, the two lines will intersect at one unique point, which means that they have a one unique solution. If any of the pairs have a solution, it comes under consistent. Then second case, coincident graph. A1 by A2 equal to B1 by B2 equal to C1 by C2. If all three ratios are equal to each other, then the graph will be an coincident graph. The two lines, the AB line and the CD line, the two lines will overlap each other, so they have infinite number of solution. If they have infinite number of solution, it is also comes under consistent, and also they are dependent on each other. Parallel graph. If the ratios A1 by A2 equal to B1 by B2 not equal to C1 by C2, the two lines are parallel to each other. There is no point of contact, which means that they don't have any solution. So it is comes under inconsistent. So by using this ratio without drawing a graph, we can analyze whether it is an intersecting graph, coincident graph or parallel graph. Sometimes the problem will be related to check whether it is a consistent or inconsistent or consistent dependent. So based on this, let me continue with exercise 3.1 question number 2. Thank you.